Hey, we're the Educational Trajectories in North Carolina Data Plus team, and this summer we've been working with the North Carolina Education Research Data Center, and they've provided us with ample North Carolina public school data dating back to around 2010. I will say there have been some limitations with this data as the formatting changes year to year, and there are a lot of changes in how they do things with the variables in the data set. So a lot of our initial time was spent cleaning the data for our purposes, but eventually we were able to investigate three main research questions, which we can see pictured in the top left of our poster. So introducing our first research question, this had to do with student trajectories in GPA and standardized test scores during COVID-19. As far as the GPA analysis, students' unweighted GPAs actually increased during the 2019 to 2020 academic year when COVID initially hit. And I did some more research into this and found that North Carolina actually instituted a policy that year that allowed students to pass-fail their spring semester courses, and that likely led to that. And then as far as weighted GPA changes, weighted GPA actually decreased a lot the following year in 2020 to 21, and this was likely a result of students opting out of advanced courses or just schools not being able to offer those advanced courses in an online setting. And then in terms of our SAT analysis, there actually was an increase in SAT scores post-COVID, but this doesn't quite tell the whole picture because there was also a sharp decrease in the amount of people taking the tests, and most of the people that would have been taking the test are the most competitive students. So this introduced selection bias into the people who are taking the test. So after correcting for this, using a logistic regression model and doing inverse propensity weighting, I found that this indeed was the reason for this score increase, and it was very artificial, and a lot of the actual increase in score was just a result of a different pool of test takers.
Let's move on to our analysis on the effect of the gifted label. So giftedness is a real tag given out by the North Carolina Department of Public Instruction and by the school districts. It's given to students who teachers and administrators and parents think might benefit from the sort of additional resources that gifted children get. And what we want to do is we want to quantify the effect of this AIG, this gifted label, on a student's academic trajectory. So how we're going to do this? Through a causal inference study. And we've simulated a randomized controlled trial by making pairs of students within the same school district. So these pairs of students, they look very similar demographically, test score-wise, before one of them is labeled gifted. So essentially we have a treatment group, the students who are labeled gifted, and a control group, the equivalent pairs who are not labeled gifted. And so the sort of charts that you see in the middle, those show average treatment effects, they show difference in difference, and they show more of the sort of difference, the average difference between a gifted student in a pair and a non-gifted student in a pair. And the summary of those is that the gifted student is going to do better on average, and that's not the end-all be-all. You can see, especially in those the histograms at the bottom, that some gifted students are going to do less well than their gifted peers, especially as you move into high school, as the effects of the gifted program wane. The longer you're in the gifted program and the earlier you're in the gifted program, the greater the effects. Let's also discuss our machine learning model to predict high school dropout. So we want to identify the key predictors of high school dropout to enable the Department of Public Instruction to stage some interventions to keep more students in school. The DPI has a vested interest in keeping its students in school and getting all North Carolinians through high school. And so we've used XGBoost to predict student dropout, And we're doing this only with pre-high school variables. So we're looking at 8th grade and earlier. And so we just sort of want to have this sort of predictive power before high school. So can we stage some intervention before high school to say, hey, you might be at risk, like, is there something you can do to decrease your rate of dropout? And so you'll see our model results. Our ROC is very good, it's 0.9, but the caveat that in our confusion matrix, the precision for the minority class, which is the dropout class, which is incredibly undersampled, only 3% of students drop out of high school in our data. And so you'll see that our precision is terrible for this minority class. You'll see it's 0.09. It's, it says 500-ish to like 4,000 students. This isn't very good. That being said, we're okay with this sort of sacrifice. Our model doesn't have to be perfect, and it's not going to be perfect. It's not taking any data from high school. There's no measures of sort of family values. Do parents have an interest in their child's education, which would give a much better picture of, high school dropouts, let's say. And so, yes, our model doesn't do a great job of predicting all of the students that drop out, but that's okay. It's over predicting the students that might drop out. And what's important is that administrators and teachers and parents can stage interventions for those students, for all of those students rather, even if they aren't going to end up dropping out. Hindsight is 20/20. But even if they don't end up dropping out, an intervention can still be helpful in limiting the dropout rates in North Carolina. And so you'll see in our SHAP plot, the most important factors: absence rate, especially in 8th grade, 7th grade, and standardized test scores. And so, yeah, that's something that's very pointed that administrators can take and say, let's get attendance numbers up in middle school, and let's try and decrease dropout in high school. That's all we've got. Thank you for listening. Thank you to everyone that's helped us in the process.